So we take the example of nickel. We want to spray nickel, and we would like to know which particle size range and which parameters are suitable for spraying nickel. So we use initially PSM, particle selection map, which is giving you a rough estimation of the spraying parameters. And in the top scroll button, you see material selection. So we select nickel 99.97% purity. For now, we take the same nozzle, by default D24WC, tungsten carbide, and nitrogen as process gas. Here you have the gas temperature range between 0 and 1000 Celsius. And we start with the temperature 600 and the gas pressure between 0 and 60 bar. Start with 40 bar pressure, and the particle diameter in the range between 1 and 150 microns, which is typically too wide a range for cold spraying. Now, what we like to get out of the calculations is the eta parameter, the cold spray quality parameter, as a function of particle size, because we would like to know which particle size is optimal for this purpose. And also we take a contour plot of eta as a function of temperature and pressure of the process gas. Click on update. So the first plot shows variation of the eta parameter versus particle diameter. And the vertical line shows the selection of the particle size within the range of 1 to 150. And incidentally, the largest eta parameter, the maximum value, is around 25 micron. So it shows that within the range of 25 or 15 to 40 microns, you have the largest eta parameter. So it shows that the particle size distribution within that range would be ideal for spraying nickel. And we go down to have a look at the particle parameter selection map. And here you see contour plots of the eta parameter. Each region is shown by a different color, and the legend shows the values here. For the selected parameters of temperature and pressure, 600 Celsius and 40 bar respectively, you are in the region between 1.2 and 1.3, but to see the accurate value of the eta parameter, you can also have a look at this table here. So eta is about 1.2, which is okay in the sense that you can have some deposition, but it's not ideal because it's a bit too low for the optimal spraying conditions. So in order to improve the conditions, we can change the temperature going up to 900 Celsius, and also we can change pressure from 40 to 50 bar and calculate again. It's interesting to notice that the eta value as a function of particle diameter has not changed very much, so that still around 25 micron particle size is optimal. But here you see that we have entered a different region of eta parameter, which is more favorable for this purpose. So eta is for the new parameters around 1.5, which is close to the benchmark for cold spraying. So eta equal 1.5 is normally favorable for cold spraying purposes. So this parameter selection map calculation tells us that the size distribution for nickel particle for cold spraying with high pressure equipment is around 25 microns, let's say between 15 and 40 microns. And also the optimal parameters for spraying with nitrogen are around 900 degrees C for gas temperature and 50 bar for pressure. In order to do more accurate calculations, then one can proceed to the simulation, which is the next step.